Hello everyone. In this module, we continue with the remaining features of Matplotlib plot. One more feature of Matplotlib is adding ligand. Basically, ligand defines what each line means in the figure. And to add a ligand in the plot, we use the ligand function of the pyplot module. There are four call signatures for the ligand function, which I discuss one by one. The first call signature is a ligand, and the syntax is like matplotlib pyplot ligand, and this method is used when no argument are passed to the function and the elements are automatically detected. And in this case, we define the labels in the plot function. So let's see an example of this method to better understand the concept. In the previous module, we add the label and the title to the plot. So in this same example, I show you how to add a ligand. Now to add a ligand, we have to use the ligand function between the show function and the plot function. So here I add a comment so you don't get confused. Ligand function using ligand method. So for this you have to write plt dot ligand only, and the label which we want to show at the ligand is added in the plot function. So here I define label and pass the label which I want to print. So I pass line 1. Now I execute this code. See what changes occur in the plot. Now you can see that here a line 1 is added. This line 1 is the ligand, and it automatically choose the best position to add the ligand in the plot. Now see the second method, that is ligand, and in ligand we pass the labels. This method can be used to generate the ligand for element that are already on the axis, and using an iterable of a string. The method is called, and with each string working as a label, the element in the sequence were created. So let's see the syntax. The syntax is like matplotlib pyplot ligand, and ligand we pass the label list. So let's see an example. I comment out the previous signature, and here I add the another one, ligand using ligand label method, and here I add. For this we have to write plt dot ligand and braces start. In braces we have to pass the list of the labels which we want to print. So here I write line 1. In the previous case we add the label at the plot function. In this case we add this label at the ligand function. So from here I remove this as we don't need it. So now I execute this program and see what happens. It works same as the previous. The ligand shows in the plot. Now see the third signature, which is ligand, and in braces we pass the handles and the labels. So this method is used to define the elements and the labels. In this function we pass the iterable list of element followed by the iterable string of the labels also in arranged order. The order we specify in this ligand function, the same order we will get on the plot. And the syntax is like matplotlib pyplot ligand labels and handles. Now let's see an example. I again comment out the previous signature and add the latest one, ligand using ligand handles and label. Now I show you how it works. Now you have to write plt dot ligand, then braces start, and then we have to write handles, and in handles we have to pass out the list of the elements. So the element list means the plot function we are using. For this we have to define the variable in front of a plot function. So I write line 1 and then I write a comma. Adding comma is a necessary as it make it as a tuple. Otherwise if you don't put the comma, error will generated. So here I write the line 1, then I add labels, and then I pass string of a label which we want to add. Here I write line 1 and now I execute this example. Here you see that error generated. This error is generated because the handle spelling is wrongly written. So I rectify it. Now I execute this again and now you can see that it again add a ligand the plot. Now I show you what happen if I remove this comma. Now I execute it. You can see that no ligand appear on the plot. So that's why adding comma is very important step. Now we move to the last call signature, that is ligand, and in braces we pass the handles only. Basically this method is similar to the ligand label method which I describe you at the second point, but it takes the labels from the plot function and iterable the element. So I show you the example. First I comment out the previous one. Now I add the new method ligand passing handle. So I add plt dot ligand and then I pass handles and the list of the element which I specify line 1. I show you where I write line 1. Here I write line 1. But where's the label? What it prints in the ligand? So the label is provided in the plot function. So here I write label. Here I write line 1. Now I execute. You can see here the ligand added on the plot. I hope you clearly understand all these four signatures. Now we discuss the parameters used by these four signatures. So these are the parameters. First one is a handles. The value is a sequence of a line and it represents the list of lines added to the ligand. The next one is a labels. It is a list of a string. Basically it defines the list of labels to show next to the lines. The another parameter is a lock, which we know it is a location parameter. It takes the value in the string format or the pair of a float. It can take 2 tuples value or a 4 tuple value. So it shows the position of the ligand where it represents. The next parameter is ncol, which is number of columns. It takes the value in the int and it represents the number of columns that the ligand has. The another parameter is a prop. It has none or a dictionary value. Basically it specifies the font properties of the ligand. The another is a font size. It has a value in integer, or you can also represent as a xx small, x small, medium, large, extra large and anything else. It specifies the font size of the ligand. The another parameter is a label color. It takes the value in the string form or the list form and it specifies the color of the text in the ligand. The another parameter is a face color. We can pass color to it and by default it has a white color. Basically specifies the background color of the ligand. The another parameter is a edge color. It also takes values in the color name and by default it has a black value and it specifies the ligand's edge color. The another parameter is title, which takes the value in the string format and it is the title added to the ligand box. With this we learn that all these four functions are used to present ligand on the plot. Now we move to the next feature. Wait, I will show you the previous plot first. So in this plot you see that the background of the graph was a completely blank. It might be nicer for this plot, but maybe in some situation we want a plot with reference system as it helps the reader to understand the plot better. So in such cases we add a grid on the plot, grid lines on the plot. So to add a grid lines on the plot we call the grid function and the syntax is matplotlib pyplot grid and the various parameters are passed to this function. So firstly I discuss the parameter, then we move toward the example. Here are the parameters. The first parameter is a visible. It takes the value in the boolean and by default it has a true value. To enable the grid lines we have to set the value true, otherwise we have to set this value to the false, and if we don't pass any value to this it always take the true value. The next parameter is a which have values major, minor or a both. In graph we have two limits, major limit or a minor limit lines. So which grid line we want to choose we can set by using which function. The next parameter is a axis. The value it has both x and a y. Basically specify on which axis we want to add a grid line. And in last we have kw arguments which have line properties as a value. Basically, it changes the properties of the grid line. So let's see an example. Now in this previous plot, I add grid lines. So here I comment out first. Then to add a grid line, we have to call a grid function between the pie plot and the show function. And without any parameter, I execute this program, and here you see that the plot comes with the grid lines at both the axes by default. I show you one more example. What happen if I pass visible parameter and set it value to true? Now I execute this. Now you can see that no change occurs in this plot as I pass the visible parameter and set it value to true, and by default the function also takes the true value. Now what happens if I pass the axis parameter to it also and I set it value to x? Now see what changes occur. Now you can see that only the grid lines occur at the x-axis, not on the y-axis. Now see what happens if I set the visible parameter to the false. Now see, no grid lines present on the plot. I hope you clearly understand what the grid function does. Now we move to the next function, that is handling axes. As you have noticed in the previous plots that Matplotlib automatically set the limits to perfectly contain the plotted data set. But maybe in some situation we wish to set our own axis limits. So for this Matplotlib provide us the different function. We discuss each one by one. The first function is a axis method. This function sets the limit for x-axis and y-axis both. We can set maximum or a minimum limit for the both the axes, and you can call this function by using any call signature, by using a keyword argument, or by simply passing the arguments. Now I show you how to handle axis. For this I use the axis function. Here I firstly pass x min value and set it to 2. X max value I set to 5. Then I set y min value to 1 and y max value to 3. Now I execute this program. Now see what happens. You can see no lines appear on the plot. Now I try to change it. Now I xy set as a -1 and x max set to the 2. Now see what happens. You can see now the lines plot in this way, and you can see the limits of the plot set as per our choice. Now we learn the another function to handling axis. The function is xlim method, or this method is used to set the limit for only the x-axis. By using this method we can only set the minimum and the maximum limit of the x-axis, or you can also call it by passing arguments only or by using the keyword argument only. So let's see an example. Firstly I comment out the previous method, then I show you. Now see, I use the plt xlim and set its minimum value to 2 and maximum value to 9. Now see what happens. Now you can see that it only alters the x-axis limit. The y-axis limit remains same, automatically adjusted by the matplotlib. Now the third function to set the limits is ylim, and it is used to set the limit only for the y-axis. By using this function we can set minimum and the maximum limit of the y-axis only, and it also has the same syntax matplotlib pyplot ylim, and in this we pass arguments or a keyword arguments which we want to pass as per our wish. So let's see an example. Firstly I comment out this and now I show you what happened. Plt ylim, and I set its value to -0.5 to 0.75. Now I execute this program. With this you clearly see that on the x-axis the limits automatically adjust by the matplotlib, and on the y-axis the limits which we pass is set. So with this we learn how to handle the limits of the plot. With this we learn all the features of a Matplotlib plot, and in the next module we will learn how to save plot in our local memory.